Hello, Physics Nation. My name is Nate Lamond, and I'd like to build a spreadsheet associated with this experiment. Human power output and heart rate is a function of time to do 20 chair step-ups. So I've tried to give you some orientation about what work is, force times distance, power is, work divided by time. Here's the sample calculation, and we saw how the rate that we did exercise affected our heart rate. So that was the last calculation. So we're basically changing this, that is text, into symbolic notation, into numerical notation. This is the sample calculation I used in the video. My kid's 68 pounds. That is roughly 300 newtons. The chair height is roughly half a meter, so that means he does about 150 joules of work when he lifts himself once, except he lifted himself 20 times, so he did 2,900 joules of work. He did that work in 54 seconds, which is kind of a weird mathematical coincidence. 54 squared is 2,900, so 2,900 divided by 54 is 54. He put about 54 watts of power out while he was doing exercise. That is 54 joules per second were being transferred or transformed. And finally, we saw how that affected his heart rate. I took his pulse, and he had 20 beats in 10 seconds, so that equals 120 beats per minute. So like I said, the goal of this is to produce a spreadsheet. And, we're just plowing through the checklist here. So we got name, date, statement of purpose. Sample calculation is these steps: hand-drawn diagram, hand-drawn symbolic and numerical measurements and assumptions, algebraic manipulations and expressions, and here we go. Let's make a table. All right, so we want a descriptive title. We want column headings that have unit labels and parentheses. And this is the graph. So let's do one thing at a time. Let's do this table. All right, here we go. Name, date, and the statement of purpose. So it's power output and heart rate as a function of time to do 20 step-ups. So again, this is the way the math teachers say it. Here, I'm going to Control A and bump up the font a little bit so it's a little bit easier to read. How about we do 24? There we go. Again, this is how the math teachers say it. They say y as a function of x. So power output as a function of time, heart rate as a function of time. This is the independent variable over here. I only showed you Sid do one set, but for this experiment, you're going to vary the pace. Where is it? Vary the pace with which you do the set of 20 chair step-ups. So that's our independent variable. This is an old set I did. We're going to try to go from this blank to this. Nice clean table. All right, so traditionally, the independent variable is the first column. And like I said, we're changing pace. So I'm going to make that my first column. And pace is measured in time, basically. So the time to do 20 step-ups. I thought I selected all. All right. And what else are we keeping track of? Well, you really just want to go through the sample calculation. Where is it? Here. And make this a column, and this a column, and this a column, and this a column. So the point of the sample calculation is like a cookbook. Do this, do this, do this, do this, do this. And each one of these measurements or calculations becomes a column in our data table. So you can see I'm running out of time, but we're going to have force in pounds. And then we're going to have mass in kilos, and so on and so on. And I'll preload some of these columns and see you in the next video.